Everyone's using Python in Power Platform wrong. Yes, wrong. Microsoft hands people a chef's knife and half of them are using it to spread butter. You've probably seen it. Someone hears Python now runs natively in Power Platform and immediately tries to rebuild an ETL pipeline, then wonders why their flow times out like a toddler denied an iPad. Here's the problem. Microsoft quietly dropped native Python support through something called the code interpreter. It's astonishingly convenient. Literally plug a Python command into Copilot and it runs right there in your environment. Yet, somehow everyone keeps overcomplicating things. They still deploy Azure Functions for trivial file conversions or numerical calculations that could have been done right inside the chat prompt. And yes, the inverse is equally foolish, running massive enterprise workloads inside a prompt like it's a hobby project. The confusion stems from this misconception that both tools do the same thing. They don't. One's a sandboxed scratchpad designed for quick experimentation. The other's a fully managed production-grade runtime. Mixing them up is like confusing microwave popcorn with a Michelin kitchen. So let's simplify. Code interpreter is instant ramen, fast, packaged, self-contained, but no one should live on it. Azure Functions, on the other hand, is the full culinary setup, knives, pans, and fire extinguishers included. By the end of this explanation, you'll know exactly when to use which and when to stop embarrassing your tenant admins with half-baked data automation experiments. Now let's talk about where all this confusion really starts, inside Microsoft's shiny new Python sandbox. Enter the code interpreter, Python's new sandbox. The code interpreter didn't emerge from nowhere. It crawled out of Copilot Studio, the part of Microsoft 365 where chatbots and automation meet polite chaos. For years, makers begged for native scripting instead of clunky connectors. Microsoft finally relented and suddenly Python appeared like divine intervention. Well, almost. Here's how it actually works. When you type a prompt in Copilot Studio, say convert this CSV into an Excel report with a pie chart, the underlying large language model does two things. First, it writes a Python script to perform the task. Then, instead of sending that code off to the cloud's wilderness, it runs it inside a sealed sandbox. Think of it as a glass terrarium for Python. Alive, self-contained, but absolutely forbidden from climbing out. All execution happens within that sandbox. It can read input files, transform them, calculate statistics, even draw charts. You get deterministic, repeatable results because the code doesn't change between runs. It's generated once during testing, frozen, and re-executed consistently. No mysterious AI hallucinations, no inconsistent outputs, just reliable automation. But here's the governance twist most users ignore. The feature is disabled by default. Administrators must explicitly enable code generation and execution in Copilot inside the Power Platform Admin Center on a per-environment basis. Why? Because letting random users execute arbitrary code in corporate environments is, minor detail, a potential catastrophe. Microsoft wisely forces admins to flip the switch intentionally. So what exactly can it do when enabled? Quite a lot within its walls. You can use it for lightweight analytics, CSV to Excel transformations, file conversions, or simple Dataverse automation. It's impressive for tasks like cleaning data, summarizing sales, and generating visual reports, all without leaving Power Automate or Copilot Studio. For analysts, this is revolutionary. No need for external scripts, task schedulers, or deployed infrastructure. Naturally, the limitations arrive just as you start to enjoy yourself. The runtime is read-only, no database writes except through permitted APIs. There's a 512 megabyte file cap, timeouts on longer executions, and a ban on external API calls, meaning no direct web requests, no pip installs, and no clever workarounds. It's a closed circuit, intentionally tamed to protect data integrity and prevent creative disasters. And yes, that frustrates developers who insist on infinite control. But in truth, that's the point. The code interpreter democratizes Python for business users without handing them the keys to the data center. It makes Python safe, like giving toddlers dull scissors. You can experiment, automate, and perform repeatable data prep, but you won't melt the firewall in the process. In short, it's the friendliest Python runtime Microsoft has ever shipped. A sandbox for curiosity, not a platform for pipelines. But once your ambitions exceed that little garden, when you start thinking about 10,000 records, nightly jobs, or integrations that stretch beyond Microsoft's walls, you'll hit the fence fast. That's the moment when the instant ramen runs out and you realize you actually need a proper kitchen. And that kitchen, it's Azure Functions. Azure Functions, Python without training wheels. Now step out of the sandbox. Azure Functions is where Python stops pretending to be harmless. It's the same language, but now it's running with full access to real infrastructure, network endpoints, and production systems. Think of it as moving from a chemistry set in your kitchen to a fully equipped laboratory. Flammable materials, yes, but also protocols and ventilation. Here's the simplest definition. Azure Functions is Microsoft's serverless platform for running code on demand. You don't worry about servers, scaling, or maintenance. You write a Python function, deploy it, and Azure handles the rest, triggering your code whenever something happens, an HTTP request, a queue message, or a scheduled timer. In Power Platform terms, it's the muscle behind the low-code facade. Your Flow or Power App sends a request and the function executes precise versioned logic. Architecturally, it's night and day compared to Code Interpreter. The Code Interpreter executes tiny Python snippets within a prompt, stateless, context-limited, and ephemeral. Azure Functions, in contrast, behaves like an event-driven microservice. It can persist state externally, fan out millions of concurrent executions, and stay alive long enough to complete actual workloads. It's infrastructure without visible servers, hence serverless. Developers love it for one big reason: freedom. You can import Python packages, manage dependencies through requirements, TXT, or use the new V2 programming model, which finally feels like standard Python instead of an exotic Azure dialect. You get proper version control, testing pipelines, and CI/CD integration. Small tweak, push to GitHub, trigger deployment, done. No mysterious prompts, no LLM interpretations, just code running exactly as you wrote it. Security, meanwhile, stops being a passive checkbox and becomes an engineering discipline. Functions can use API keys for simple access, OAuth for secure app calls, or managed identities that authenticate to other Azure resources without storing secrets. You can even wrap them inside virtual networks, ensuring only internal services can call them. In enterprise terms, this is gold: auditable, enforceable, and fully logged. Scalability is the part that makes you blink. Azure Functions scales automatically from 0 to infinity, or more precisely, from idle to as many concurrent executions as your account allows. When no one calls your function, it sleeps. When 1,000 Power Automate flows invoke it simultaneously, it wakes up 1,000 times over. Each instance operates independently, then disappears when it's done. The billing meters only when it runs, so cost aligns perfectly with usage. Code Interpreter can't do this. It's fixed to a single execution window inside one chat session. Governance and monitoring are equally serious. In Azure, every function emits logs and metrics. You can view execution histories, exceptions, response times, and even memory footprints. Application insights and log analytics turn that data into dashboards that IT actually approves of. Compare that to Code Interpreter, where your only audit trail is a chat history and a half-trustworthy output pane. One looks like enterprise IT, the other feels like science fair. Here's a practical example. Imagine an enterprise uploading gigabytes of sales data every day. A junior analyst might try running Python through Code Interpreter to clean and summarize it until the file limit smacks them in the face at 512 MB. Timeout. Failure. The same job, ported to an Azure function, would stream chunks, process them concurrently, and finish before the analyst's coffee cooled. The function doesn't panic, it scales. So why does anyone still cling to the Code Interpreter? Because it feels easier. It's instant feedback, zero deployment, zero friction. But easy and appropriate aren't synonyms. Azure Functions demands discipline. You must define structure, handle secrets correctly, and manage versions. Yet the payoff is professional reliability, code that isn't just clever but sustainable. In short, Azure Functions is Python without training wheels. It lets you integrate with APIs, automate at scale, and plug into enterprise systems responsibly. It's the grown-up choice, not as charming as a chat box, but infinitely more capable. And yes, it solves the problem that no prompt ever will: consistency across every user, every environment, every run. So now that you've seen both ends of Microsoft's Python spectrum, sandboxed playpen versus industrial kitchen, let's discuss the trap most teams fall into: confusing convenience for capability. The illusion of convenience, where most teams go wrong. Here's the tragedy of convenience. People think Code Interpreter means production Python. It doesn't. It means please don't bite the hand that feeds you. And yet every week someone drags a 400 MB CSV into Copilot Studio, hits run, and proudly declares they've automated data ingestion. Seconds later, timeout, then panic. Then a Teams thread titled, "Why is Python broken?" The core misunderstanding is architectural. Code Interpreter isn't a data pipeline engine, it's a polite sandbox pretending to be one. It was designed for interactive transformations: clean this file, summarize that dataset, not sustained, multi-step batch jobs that churn overnight. But many teams treat it like an unlicensed copy of Azure Data Factory, with predictably catastrophic results. Here's what actually happens. The sandbox spins up, runs your generated Python, and dies. That's it. No persistent environment, no retained context, no dependency management. You can't pip install your favorite package, you can't allocate more RAM, and you definitely can't call external APIs or databases unless Microsoft pre-approves the endpoint. In short, it's hermetically sealed for safety. But users interpret safe as limitless. They stack logic on top of logic, chaining prompts, refeeding outputs like they're debugging in Notepad. Eventually, performance plummets, sessions vanish, results disagree with yesterday's run. Then, having learned nothing, someone decides to schedule it hourly. Brilliant, now they've industrialized failure. The illusion is economic too. It feels cheaper because it hides the cost behind licensing. Why spin up Azure resources, they argue, when Python runs inside Power Platform already? Yes, and why rent an apartment when you can live in a cardboard box? It's technically free right up until it rains. Code Interpreter was never built for sustained automation. Its runtime is metered, ephemeral, and capped by quotas that exist precisely to prevent you from turning it into a data furnace. Meanwhile, real governance goes out the window. With Code Interpreter, there's minimal telemetry, no application insights, no centralized logging, no immutable audit trail. When something fails, you get a vague error and a shrug. In enterprises, that's not automation. That's an untraceable incident waiting to happen. Compare that to Azure Functions. Every execution logged, every exception traceable, every environment versioned. IT teams prefer it not because they're joyless bureaucrats, but because accountability is non-negotiable. You don't fix bugs by hoping the next prompt works better. You fix them by deploying tested code with continuous integration. And if you don't know what that is, congratulations, you've just discovered why your flow keeps breaking. Still, the seduction of convenience is strong. Code Interpreter delivers dopamine on demand, instant output, pretty charts, no infrastructure drama. People mistake that for maturity. But professional architecture isn't about how quickly you start working, it's about whether the thing still works 6 months later when you're on vacation. Azure Functions is boring precisely because it survives turnover, migration, and human error. So keep using Code Interpreter for what it is, an interactive assistant that makes analysts feel like developers. But don't ask it to run your nightly ETL. That's like expecting Excel macros to manage your supply chain. Convenience has a place, just not the one most teams stick it. Use it to prototype, test ideas, or validate logic. Then, when it matters, graduate to the grown-up environment. Otherwise, enjoy explaining to your administrator why your quick automation consumed half your tenant's compute quota. Spoiler, they won't find it funny. The decision framework, when to use which. Most people don't need another feature tour, they need a rulebook. So here it is, the sanity-preserving framework that separates proper architecture from chatbot chaos. Think of this as the table your future self will print and tape above their monitor, labeled when not to embarrass it. First rule, scope defines structure. Use Code Interpreter when your task is immediate, local, and disposable. Use Azure Functions when it's recurring, global, or business critical. Code Interpreter thrives on singular moments, transforming a file for a meeting, running a one-off analysis, producing that coveted quick win. Azure Functions, by contrast, lives for repeatability, integration, and scale. If it needs versioning, monitoring, or an owner with a job title longer than enthusiast, it belongs in Azure. Governance is the next divide. The Code Interpreter exists per environment, tucked inside Copilot Studio's safe boundaries. It's experimental, almost personal. Each environment must have the feature explicitly enabled by an admin. Think of it as sanctioned curiosity. Azure Functions, meanwhile, is codified protocol, centrally controlled, policy enforced, and auditable through Azure Monitor or Sentinel. If your compliance officer can spell ISO, you already know which side they prefer. Security follows naturally. Code Interpreter protects you from yourself through sealed sandboxes. It can touch files you upload, but not the internet beyond Microsoft's permits. No requests library, no browsing, no exfiltration. Ideal for an analyst cleaning data, terrible for an integrator connecting to SAP. Azure Functions flips that balance. It operates within managed identities, can sit inside virtual networks, and authenticate via OAuth. Secrets dwell in Key Vault, not inside prompts. So if you're asking, can I safely call an external API or database? The answer is yes, just not from the interpreter. Scalability is where the line becomes mathematical. The interpreter handles one session, singular, synchronous, human-paced. It starts when you ask and ends when the output's done. Azure Functions, on the other hand, is parallelism unleashed. It scales horizontally across tenants, bursts under load, and waits politely when idle. If your workload could multiply, Azure Functions will thrive. If it's just you watching it run, Code Interpreter is fine. Maintenance costs tell another story. Code Interpreter requires no pipelines, builds, or dependency headaches, just prompt tuning. But that simplicity evaporates once the logic grows. Prompts lack true version control. One mistyped instruction and behavior mutates overnight. Azure Functions anchors itself in Git or DevOps pipelines. Every commit, every deployment, every rollback is traceable. Bugs are documented since, not mysteries. So when colleagues demand, run the version we used last quarter, Functions actually can. Now let's translate this into human roles. Picture two professionals, the analyst and the architect. The analyst lives in Power BI and Excel, obsessed with data transformations and visualization. Their job ends when insight appears. For them, Code Interpreter is ideal. Generate Python snippets that summarize CSVs, produce visuals, and send quick outputs in Copilot Studio. Temporary, contained, effective. The architect, however, designs systems that must not explode when touched by power users. They think in tenant boundaries, not CSVs. Their world involves pipelines, authentication flows, and dependencies between half the company's services. For them, Azure Functions is the obvious choice. They need predictable scaling, deployment pipelines, and security compliance. The same code that the analyst tested casually in Copilot, the architect turns into a production API. That leads to my favorite hybrid pattern, the prototype to production loop. Start ideas in Code Interpreter. It's fast. No approval delays, no environment builds, just immediate feedback. Once the experiment stabilizes, say a data transformation prompt that consistently outputs the right schema, graduate it. Take the generated Python, refine it, push it to an Azure function with proper error handling, environment variables, and CI/CD. Congratulations, you've used both environments exactly as intended. The elegance of this pattern is it respects scale and governance simultaneously. Code Interpreter encourages innovation. Azure Functions systematizes it. One lowers the barrier, the other raises the standard. Skipping either makes you inefficient. Staying forever in the prompt renders your project unmanageable, forcing every minor script into Azure's mother's agility. The trick is knowing when tinkering ends and engineering begins. To summarize, though I hesitate to spoon-feed, Code Interpreter, X-source disposable, interactive, governed by Sandbox. Azure Functions, it's persistent, reusable, governed by architecture. The arrogance of scale meets the humility of governance right here. Innovation demands the freedom to try. Enterprise survival demands the discipline to systematize. Use the sandbox to think, the function to deliver, and stop pretending one tool can be both kitchen and microwave. If you follow that matrix, you won't just build faster. You'll finally build responsibly. The enterprise reality check. Governance, cost, and control. Let's talk about the part everyone claims to understand but rarely enforces. Governance. When you bring Python into an enterprise, you don't just inherit power, you inherit accountability. Power Platform's Code Interpreter gives users automation superpowers, but it also gives compliance officers night sweats. That sandbox may look sealed, but every execution is still a code run inside corporate infrastructure. And with code comes risk. Start with quotas. Microsoft didn't design limits just to be annoying. They exist to keep you from bankrupting your tenant. Each Power Platform environment caps file sizes at 512 MB, restricts sessions, and throttles daily Power Platform requests. Team subscriptions get as few as 6,000 per day. Enterprise plans stretch higher but are still finite. Once a flow crosses that line, it fails silently or stalls until midnight. Azure Functions, meanwhile, couldn't care less about quotas. It scales with your wallet. You pay by execution, time, and memory, but you define your thresholds. Predictable spending replaces hidden throttles. Then there's the security posture. Code Interpreter lives under the benevolent dictatorship of Microsoft's Sandbox. It can't call external APIs, can't reach internet addresses, and can't install malicious packages. That's good until your business process actually requires those things. One enthusiastic analyst decides to extend functionality with a custom prompt that passes financial data from an external endpoint, and suddenly governance alarms start shrieking. The Sandbox intentionally forbids outbound connections to prevent data leakage. Every execution is logged, yes, but only within that environment. There's no cross-tenant telemetry or SOT-friendly logging pipeline. Azure Functions answers that limitation with luxuriant paranoia. It authenticates through managed identities, encrypts everything in transit, and can sit inside isolated virtual networks. Want to trace every call? Application Insights documents them all with timestamps and payload metadata. IT departments sleep better knowing each request leaves a forensic footprint. Cost is another misunderstood dimension. Makers often say Code Interpreter is free because it's included. Incorrect. It's prepaid under licensing. Big difference. Each prompt consumes compute, storage, and network resources that contribute to your tenant's Power Platform capacity. Once demand spikes, administrators either pay for more capacity or start banning over-enthusiastic creators. Azure Functions, conversely, builds per execution and scales linearly. You use it, you pay for it, you stop, the meter pauses. For structured workloads, think nightly ETL or batch reports, this model wins. It converts chaos budgeting into predictable precision. Governance hierarchy completes the picture. Code Interpreter is controlled through the Power Platform Admin Center, toggled by environment. Its policy domain ends there. Azure Functions operates under Azure Policy and role-based access control. That means you can restrict deployment by role, enforce tagging standards, demand encryption at rest, and audit configuration drift. When security teams perform internal reviews, functions survive scrutiny, chat prompts not so much. Picture a typical scenario. An internal audit discovers multiple Copilot prompts executing financial data transformations with no centralized approval. The auditors trace logs, half are missing. The admin panics and disables code execution across environments overnight. Everything stops working. Cue frantic Teams messages from analysts who built half their reporting stack in prompts. Compare that with the Azure Functions approach. Code repositories, versioned releases, and monitoring dashboards. The same auditors request evidence, and IT produces a neat pipeline diagram, execution logs, and policy compliance reports. One side looks experimental, the other institutional. The moral isn't to abandon Code Interpreter, it's to understand its border. It's perfect for ideation and testing, but when real money, compliance, or customer data touch the code, you promote it. Hybrid best practice. Prototype in the Sandbox, deploy in Azure. That pattern satisfies both creativity and control. A Spark in Copilot becomes an approved microservice with provenance, telemetry, and a lifecycle. Because power without structure isn't innovation, it's entropy, and enterprises have enough of that already. Stop the misuse. So here's the line in the silicon. Code Interpreter is a phenomenal sandbox, a safe place for experimentation, small automations, and quick insights inside Copilot Studio. It democratizes Python without dismantling compliance, but it's not, under any interpretation, a production platform. Azure Functions, on the other hand, is your Python backbone, governed, auditable, and ruthlessly scalable. Using the wrong one isn't just inefficient, it insults the architecture your organization pays to maintain. Running batch pipelines in a conversational agent is like towing a trailer with a bicycle. It moves technically, but only until the axle snaps. Enterprise reliability comes from separation of intent. Prototype where it's cheap, deploy where it's controlled. So stop feeding heavy workloads into Code Interpreter and calling it automation. Start using Azure Functions for what it was built to do. Secure, versioned, repeatable logic that survives you going on holiday. Your admins will thank you, your audit logs will thank you, and remarkably, your code will still work next quarter. If this saved you time or rescued your sanity, repay the debt, subscribe, tap follow, enable notifications, and let the next update arrive like a scheduled task. On time, zero drama. Do the efficient thing now.